is there an angle formed by TP, the same chord? Angle between tangent and chord should be equal to angle made by the same chord. So this TP is making an angle 25 at S. So that 25 should be nothing but N. So can we say N equals to 25? So let's go and write N equals to 25. So this should be 25. Right? So we applied the tan chord rule. We said tangent and a chord, and that's the angle made by the same chord. Okay. So we got all that. Can you find this angle? That much only, watch there. You can apply the concept of triangle. Come on, you know now, right? It's a SPR. 3 angles add up to 180. You know 2 of them. You can find that missing one. I'm not going to find please, because we don't waste too much time in this one. Now the next one. Maybe this angle. Is there a concept you can use to find this angle there? STPR, it's a quadrilateral and a circle is passing through the four corners. The blue circle is passing through T, P, R, S. What kind of a quadrilateral is this? It's a cyclic quadrilateral. Now, what is the importance? What do you know about a cyclic quadrilateral? Opposite angles, well, you got to ignore this line now. Opposite angles add up to 180. They are supplementary. Keywords, please. Supplementary. So that's a 70. This should be 110. Right? That's how you need to find the missing angles. All different types of rules can play an important role in just a single sum. Okay? Now, can we just look at the rules that we applied in this sum now? Isosceles triangle, we just started there. So base angles equal. Then we applied sum of the 3 angles of a triangle concept. We said no, we can also apply exterior angle of a triangle. Some of the interior ones. You jump inside and add those 2 angles. Then we used cyclic quadrilateral in the end. Also, in 2 places, we applied alternate segment rule, tan chord rule. All right? Okay. We are happy. Now, we go to page 7. Right? Page 7, please. The next question is on page 7. Please turn to page 7. It just says, find all the missing angles. It's on the screen now. Find all the missing angles. Well, more or less it looks like the same type, but we have a tangent and then center point, so we should be happy. Right? Center point is there. There's a line passing through, so there is a radius and it's a tangent. What do you know about them? The angle between radius and tangent, please. Right? At the point of contact, the angle between radius and tangent is always 90. So that's a 90 there. That is a 90. Anything else? Is there anything else that we can do? In this triangle, DAB, we know nothing apart from just 90. Now, look for anything else. Well, this triangle OAC also, we know nothing apart from just that angle. Right? Now, let's look for some other rules that we learned in part 1 and 2. I can see an arc here, the green one, watch there, this arc, watch the pen please, watch the screen. This arc is making an angle 32. This arc is making an angle 32 at E. The same arc is making another angle at D. Okay. Now, according to the rules, angles in the same segment must be equal. So if that's a 32, we are looking at this angle also to be 32. Okay, right, angles in the same segment, angles made by the same arc, we got that. Now, can you manage finding the angle at the center? Try and think. Is there a way you can find this angle? Angle at the center, please. Angle at the center is twice the angle at the circumference. Okay. Now, watch that arc there. The arc makes an angle at the center and the same arc makes an angle 32. So, angle at the center should be double the angle at the circumference. So, that's a 32. This should be 64. 64, right? 32, half of this. 64, double to that. Well, we are getting there now. Watch there. Look at the triangle DAB. Can you find this angle here? It's a right angled triangle. So that's a 90 we know. Angle between radius and tangent. The top angle also we know. Ignore this green line. Watch that triangle. I know two angles. I'm looking at the next one. I'm looking at the next angle there. Now, can we find that angle? Can we find this angle here? Right? 90, 32. You got to add those two and you should get 90. So take the 30 away, which is 60. Then take the 2 away, which is 58. So that angle comes to be 58. Right? The concept we used was basic rule, sum of the three angles of a triangle. Now, can you find this angle now? The last one here. Come on, think. C. Look at the triangle OAC. Maybe you could even go for you may get a doubt. Why can't we choose EAC? In this big triangle, I know only one angle. There is no way I can find C. So let's concentrate on the smaller one, OAC, that is also a right angled triangle. The top angle there is 64 and the angle here is 90. We are looking at that angle, please. Look at the triangle there. OAC is the right angled triangle. It's a 64. Those two should add up to 90 because 90 and this 90 should be 180. You should forget about this arc and that pink line there. All right. Now, take the 60 away. We are left with 30. Take the 4 away. Then we got 26. That should be 26. Right. So that's how you find those angles now. Now, can you find this small part here? This part only. This part only. Is there a way you can find this angle? Well, turn the picture like that. Do you agree that's isosceles triangle because OE is radius and OA is also radius. So, base angles must be equal. So, that's 32. This should be 32. Then, the top angle there also will be 32. Come on. What is the reason? Well, there are two.